Hello, good morning, guys. Welcome back to our science lesson. Today is Wednesday, April 29, 2020. Our lesson for today is titled Thermal Conductivity. And our teaching point is I can explore and identify the thermal conductivity in different materials. So basically, we're going to be taking a look at how good different materials are at conducting thermal energy, right? According to their properties, we're going to be taking a look at how good they can actually perform this. So let's take a look. I just want to suggest that you pause the video now and get to copy the date, lesson name, and teaching point now, just before we jump into our question of the day. Now, our question of the day, we have the following question. What is the kind of materials that can easily transfer heat or electricity? So we got two options, insulator and conductor. I suggest that you pause the video now and get to try on your own. When you think you got the right answer, click on play. And the right one is conductor. I remember that when we were working with our previous lesson, which was all about electricity, we had the opportunity to take a look at conductors from the electricity perspective. In this time, we're going to be taking a look from the heat perspective. So we said that a conductor was any piece of material that easily allows heat or electricity to pass through it. It's like a highway, a road that allow electricity or heat to flow. Many different materials can be conductors, but metals are the best conducting materials that are available to us. That way you will see that many utensils in the kitchen are made of metal because they're pretty good conducting heat. But also, if we take a look at the wiring in our house, we will see that all the cables inside are made of metal. This metal is usually copper because of the good conductivity it's provide. Alright, you will find this wire covered in an insulator that is a cape of rubber that prevents us from getting any electrical shock. So a conductor allows electrons, yeah, to flow freely across its surface. Right, so we're still in our module energy transfer, specifically on our lesson number 4. We're trying to answer the question, what is heat? Going back to our teaching point, I can explore and identify the thermal conductivity in different materials. Thermal energy travels at different speeds. Thermal energy is carried by radiation through empty space at the speed of light. As you can see, we have an example right here that represents being these solar rays traveling through empty space in the form of wave. So convection currents travel slower. Conduction is usually slower than both radiation and convection. In conduction, it is to say when we have two objects or two materials touching each other, thermal energy must travel through all the particles of the matter. So that means that in this case, for example, that this ball is touching this ball right here, we have an example of conduction. But since we have an example of conduction, then that means that all the particles of this object will experience the energy that is being transferred by his hand. Right? So thermal conductivity, our teaching point for today, or our main concept for today. What is that? It is the ability of a material to transfer heat, right? This is what we usually call thermal conductivity. How good are certain objects at conducting heat? Right? Materials that conduct heat are usually good thermal conductors. Right? So right here we have a few examples. We have silver, aluminum, and copper that we're going to usually find them in kitchen utensils for us to cook because of their good conductivity they provide, but also in many electrical materials as well. Alright, most metals are thermal conductor. Thermal conductivity usually increases with density, but what is density? When we talk about density, we're talking about the amount of matter in an object, right? It is to say how thick they are. If we take a look at these three different samples right here, we take a look at the three main states of matter. We have gas, liquid, and solid. Now, according to their um, matter type, let's say, or actually a state of matter, we're going to see that the particles are way closer together, kind of apart, and way more apart. Now, when particles in a material are closer together, as in the case of solid, heat can move more quickly through them. Why is that? In our last experiment, our inquiry activity, we had the opportunity to take a look at an object, a metal pan, and we noticed that the particles of this metal pan were pretty close together, that way allowing the heat to be transferred from the bottom layer to the upper one and so on until the whole material was heat. So as you can see, since these are closer together, then that means that whatever energy we transfer into any of these particles, they can easily transfer to the next level because they're pretty close together, they're touching themselves. Now, if we take a look at the liquids, it still can happen, but it will be kind of difficult compared to the solid one because they got certain gaps between them. Now, if we take a look at the gases, this is actually the tougher one in order for us to transfer heat because of the way their particles are moving. They're always jumping around and these particles are pretty spread out. So the probability of having a good heat transfer here are pretty low. So as we said before, solids are better conductors than liquid, right? And liquids are better conductors than gases. So we have this scale right here. Solids are better, let's say, solids are better than liquid at conducting, and then we have liquid that are actually better conducting than gases. If we take a look at this example, we can see that this cube has the same size, right? Has the same property, let's say. Now, the only thing different between them is actually their density. Even though these two first are made of wood, right? They got actually the same shape. We can see that this one has some holes in their shape, in their construction. So that means that they have less mass. And if they have less mass, then that means that they have less density. So that means that they will float easier than this one that has a little more mass. And we can see it right here. The second one is way deeper into the water. Now, if we take a look at the last one, which seems to be made of silver or aluminum or some kind of metal, this one is way heavier because of the way its material is actually constructed. As we said before, solids are actually better at conducting energy, and their mass, and since they're solids, then the atoms, the particles that compound them, are way closer together. So that way they can actually be heavier. Right here we have an example of different liquids being poured into a vase. Even though they're liquids, we can see that they have different densities, right? They have different properties they all can actually take the shape of the basin that is pouring, but depending on their density, they will take different position, one on top of the other. This is a really nice experiment that you could try at home to actually see density on display. So an insulator We already took a look at conductors, and we said that conductors were really good at conducting heat and electricity, but now we have the opposite type of material, which are insulators. So what is that basically? So materials that conduct heat poorly are what we call thermal conductor. Well, my bad. Thermal insulators. Yeah. So if we take a look at the wire, for example, an electrical wire, you're going to see that inside we have um, the wiring, right? Basically, the piece of the wire that conducts the electricity, which is usually copper. Now, on the outside, you will find some of a cover of rubber. Why rubber? Because rubber is an insulator and it doesn't allow electricity to flow from the metal into our hand, that way keeping us safe, and that way we can actually have the electricity flowing as we need to. Air, for example, is a thermal insulator. Yes, air. Most winter coats are puffy because they contain pockets of air that prevent heat from moving away from your body. If we take a look at different examples of material that are insulators, we have glass, right here we have plastic, wood, and some rubber right here. So these materials don't easily allow electricity or heat to flow. If we take a look at um, kitchen utensil, for example, you will find that on the handle, the piece of the utensil that we can actually grab, you will find some piece of probably plastic, right? That way preventing the heat from the metal reach that part and we can actually grab it safely. Now at the end of page 74, we're going to find this table right here. In this table, we organize different materials according to how good they are conducting heat. We're going to see that at the actually the lowest level, we're going to find some wood, right? And on the upper one, we're going to find metals such as aluminum, copper, and silver. Now, so what are you going to do now? You're going to take a look at how these perform at conducting heat. And then you're going to use the evidence to explain which material from the table is the best thermal conductor. So that means that you need to identify which one and then explain why, based on the explanation that we just had, and also on the facts that are shared with you on page 74. So that will do it for today, guys. I hope that you have enjoyed this lesson. If you have any question, don't forget to text me. Now, you also have a deck toys activity where you're going to practice a few concepts that we discussed in this lesson. I hope that you have fun, and I will see you next time. Bye bye.